Hello and good day. Welcome back to our class. This is teacher Odin de Guzman. Our lesson for today is zero and negative integral exponents. In your previous lessons, you have encountered exponents. Exponents provide you with convenient way to represent and work with very large and very small numbers. In this tutorial video, you will extend your understanding on exponents, specifically on zero and negative integral exponents. Initially, you will recall the rules for positive integral exponents, and you will be able to apply these rules to zero and negative exponents. Let's begin with multiplying powers with like bases. So let's have product rule. If x is a real number and m and n are positive integers, then x raised to m times x raised to n is equal to x raised to m plus n. Or simply, we will add the exponent. Say for instance, I have a raised to 7 times a raised to 4. I'll simply add the exponent 7 plus 4 is equal to 11 and the base is a. Let's have another example. Say for instance, if I had 2 to the 5th power times 2 to the 3rd power, I'll simply add the exponents 5 plus 3 and the base is 2. So I have here which is equal to 2 raised to 8. But take note that 2 raised to 8 can be simplified as 256. Let's have another example. Say to the 4th times say to the 3rd times say to the 12th, I simply add 4 plus 3 plus 12. So I'll come up with 19 and the base is 8. So therefore, the final answer is say to the 19th power. Let's continue on problem number 4. Y raised to 9 times y. Take note that the exponent of y here is equal to 1. So it means that y raised to 9 plus 1 is equal to y raised to 10. Next example, I have here 2x raised to the 4th power times 3x raised to 7. So I'll simply multiply the numerical coefficients of 2 and 3. Okay, copy the same base and add the exponents 4 and 7. So I have here now as the product which is equal to 6 times x raised to 11. So let's move on now to the quotient rule. So if x is a real number and m and n are positive integers, then we have the expression x raised to n divided by x raised to n is equal to x raised to m minus n, provided that m is greater than n. So let's have example. So we have here x raised to 11 divided by x to the 4th power. Take note that the exponent in the numerator is greater than the exponent in the denominator. So we simply copy the same base and subtract the exponents. So I have here as the quotient as x raised to the 7th power. Let's have another example. Y raised to 6 divided by y raised to the 5th power. So we have here y raised to 6 minus 5, which is equal to 1. Supposedly, we will write here 1. But, again, to simplify this, so the final answer is equal to y. Another example, if I have here 8 raised to 10 divided by 8 raised to the first power. Okay, so we have invisible 1 here. So we can have here 8 raised to 10 minus 1 is equal to 8 raised to 9. So let's move on to raising a power to a power. So we call this one as a power rule of power of a power. So let us consider if x is a real number and m and n are positive integers, then x raised to m raised to n, we simply multiply the exponents m and n. So we have x raised to m times n. So let's consider example number 1. So if I have b raised to 2 raised to 5, so I'll simply multiply the exponents. 2 times 5 is equal to 10 and copy the same base. Let's have another example. 2 cubed squared. So again, I'll multiply the exponents. 3 times 2 is equal to 6. So I have here 2 raised to 6. Next, we have negative 2 squared cubed. Take note that the negative is outside. I'll multiply this one first. 2 times 3 will give us 6. However, we have negative outside, so we will put negative outside. Another example, number 4, a raised to 7 raised to 4. Again, multiply 7 times 4 and copy the same base. So we have here a raised to 28. Next one, y to the 4th power raised to 9. So this will give us, okay, 4 times 9 is equal to 36 and copy the same base. So let's move on to the power of a product. So if x and y are real numbers and m and n are positive integers, then x times y raised to n, we simply distribute m. So I have x raised to n times y raised to n. So example, m times n raised to 6, I'll simply distribute 6 to m and n. So I have m to the 6, n to the 6th power. Next, 4 times x raised to 7. Again, distribute 7 as exponent. So I have 4 raised to 7, x raised to 7. Another example, if I have here a squared b cubed times c to the 4th power raised to 3, I'll distribute 3. So I have here 3 times 2 will give me 6. 3 times 3 will give me 9. 3 times 4 will give us 12. So therefore, I have the product as a to the 6, b to the 9, and c to the 12th power. Let's have another example. I have here negative 3 p to the 7 raised to 4. Take note that this is even exponent, so the negative now will become positive. So I have here negative 3 to the 4th power times p raised to 7 raised to 4. So the answer is positive 3 raised to 4. Then 7 times 4 will give us 28. So the answer is 3 raised to 4 times p raised to 28. Another example, I have here 1 raised to 4 times z to the 5th power raised to 9. Again, distribute 9. So I have here y raised to 4 times 9 times z raised to 5 times 9. So therefore, we have y raised to 36, z raised to 45. Let's consider now the power of a quotient rule. So if x and y are real numbers and m and n are positive integers, then x over y raised to m. Okay, we simply distribute the exponent m to the numerator and denominator. So we have x raised to m all over y raised to n. So let's have example number 1. X over y raised to 8. So simply distribute the exponent 8. So we have x to the 8th power all over y to the 8th power. Another example, so we have negative p all over r raised to 3. Take note this is a number, so we will retain the negative sign. So I have here negative p to the 3rd power all over r to the 3rd power. Next, 2g all over h raised to 4. So again, I'll distribute 4 to both numerator and denominator. So I have here 2 to the 4th power times g to the 4th power all over h to the 4th power. So take note that 2 to the 4th power, it means that is 16. Then simply copy g to the 4th power all over h to the 4th power. Next one, I have x squared times y to the fourth power all over z to the fourth power raised to 6. Again, I'll distribute 6. So 2 times 6 will give us, okay, 2 times 6, then copy the variable x. Then we have 4 times 6, and copy the variable y. And say, raised to 4 times 6. Simplifying it further, I have here 2 times 6 is equal to 12, 4 times 6 is equal to 24, and 4 times 6 is equal to 24. And don't forget to copy the given variables. Okay, so now that we have recalled all the positive exponents, so this time we will move on now to zero exponent as well as the negative exponents. So let's tackle first the zero exponents. Take note that any non-zero real number raised to the zero power is equal to 1. That is, if x is not equal to 0, then any number raised to 0 is equal to 1. So let's have another example. 132 raised to 0 is equal to 1. Next, negative 12 raised to 0 is equal to 1. Let us consider this one. So I have the expression negative 4x raised to 0. However, I have negative outside. So I have here this expression is equal to 1, but I have negative outside. So this is equal to negative 1. Next, I have here negative 4 times x raised to 0. Take note that the old expression x is raised to 0 exponent. So that is why I have here negative 4, because this is equal to x raised to 0 is equal to 1 times negative 4. So this will give us negative 4. Let's move on to negative exponents. A non-real number raised to a negative power is multiplicative inverse, or commonly known as reciprocal, of the number raised to the positive opposite of the power. That is, if x is not equal to 0 and m is a positive integer, then if I have expression x raised to negative m, to make this positive exponent, I'll put it in denominator. So I have here 1 all over x raised to n. Or if I have here exponent in denominator as negative, so to make this positive, I'll put it in the numerator. Take note that x raised to n times 1 will give us x raised to n. So let's have example. I have here y raised to negative 8. To make this exponent positive, I'll put it in denominator. And don't forget our numerator is equal to 1. Another example. I have here 1 all over h raised to negative 5. To make the exponent positive, I'll put it in the numerator. But take note that I have here 1. So I have here 1 times h to the fifth power will give me h to the fifth power. Let us try more examples on negative and zero exponents. So I have here example number 1. So I have here 5, m raised to negative 3, and raised to 0 raised to 2. So we can distribute 2 now. So I have here 5 squared, m raised to negative 3 times 2, times n raised to 0 times 2. So I have here 5 squared is 25. Then I have negative 3 times 2 will give us negative 6. Then we have n raised to 0. Simplifying it further, I have 25. But take note that n raised to 0 is equal to 1. Then to make this m raised to negative 6 as positive, I'll put it in denominator. So therefore, I have here 25 times 1 is equal to 25 all over n raised to 6. Let's have example number 2. So I have here 4d squared h raised to negative 5 raised to 3 divided by 2 times d raised to negative 1 h raised to 5 raised to negative 2. So I can distribute the exponents in the numerator and denominator. So I have here 4 raised to 3 times d raised to 2 times 3 times h raised to negative 5 times 3 divided by, okay, I'll distribute negative 2. So 2 raised to negative 2. Then I have here d raised to negative 1 times negative 2 times h raised to 5 raised to negative 2. Simplifying it further, I have here 4 raised to 3 is equal to 64. Then we have here d raised to 6, h raised to negative 15. Then I have here 2 raised to negative 4, d squared, h raised to negative 10. Simplifying it further, I have here, take note that to make this one 2 raised to negative 2 as positive, I'll put it in the numerator. So I have now here 2 raised to 2 times 64, d raised to 6, h raised to 10, because I put h raised to negative 10 from denominator, so it is now h raised to 10. Then I have d squared all over, okay, d squared times h raised to 15. Simplifying it further, I can have here 2 squared is equal to 4 times 64 is equal to 256. Now, I can factor out h raised to 10. Okay, then we have h raised to 15. Remember that since the exponent in the denominator is greater, so I simply subtract 15 minus 10 is equal to 5. Then I have here d raised to 6 divided by d squared. So since the exponent in the numerator is greater, so I subtract 6 minus 2. So I have here d raised to 4. So therefore, the final answer is equal to 256 d to the 4th power all over h raised to 5. Let's have another example. So if I have negative 9 a to the 8 b raised to negative 3, then I had divided by 6b squared a raised to negative 4. Again, I'll consider first to transfer all negatives exponents. So I have here negative 9 a raised to 8. I'll move negative 4 to the numerator and negative 3 to the denominator. Next, so I have here, I'll combine 8 plus 4 is equal to 12 and copy the same denominator. So next, I add 2 and 3, so I have 5 and copy B as my base. Then I'll simplify it further. So negative 9 and 6 is divisible by 3. So I have here negative 3 a to the 12th power all over 2b to the 5th power. Example number 4. I have here 1 half x raised to negative 2, y raised to 5, z to the negative 3. Take note that I can rewrite this one as 1 half times. This x raised to negative 2 can be rewritten as 1 all over, all over x squared. Then I have y raised to 5. This z to the negative 3 can be rewritten as 1 all over z raised to the 3rd power. Take note that it is like an ordinary fraction, so I can simply multiply the numerators 1 times y to the 5th power times 1. So this can be rewritten as y to the 5th power. On the denominator, I have here 2 times x squared times z to the 3rd power. So therefore, the final answer is equal to y to the 5th power all over 2x squared z to the 3rd power. So let's move on to problem number 5. So I have 143xy raised to 0, d raised to negative 8 divided by d raised to negative 5. Take note that this expression 143xy raised to 0 is equal to 1. Then I'll move this one in the numerator to make it positive. Then d raised to negative 8, I'll put it on denominator. So I have here now d raised to 5 all over d raised to 8 because 1 times d to the 5th power is d to the 5th power all over d raised to 8. However, using the positive law of exponents, since the exponent in denominator is greater, so I'll deduct the exponent in denominator and copy the same base. So I have here 1 all over d raised to 8 minus 5. So the final answer is equal to 1 all over d raised to 3. Let's move on to example number 6. I have here 4 raised to negative 4 n raised to negative 1 all over 4 n raised to the 3rd power. Now, I can put all these negative exponents in the denominator to make it positive. So I have now just simply as 4 in the numerator. In the denominators, I have 4 raised to n to the fourth power. Then I have n cubed times n to the first power. So I can combine here n to the third power times n to the first power. So I have here n raised to 3 plus 1 and copy 4 m to the fourth power as 4. But take note, I can factor out 4 and 4, so this give me numerator as 1. Then I have n to the fourth power, n to the fourth power. So therefore, the final answer is equal to 1 all over m to the fourth power, n to the fourth power. So that ends our discussion. So hopefully you learn something. Again, so this is teacher on this month. So don't forget to subscribe for my channel so that you will be informed of my new videos.